So the next good afternoon. So next part has been continued here for our next theorem 47. Next theorem 47. Okay. So that the statement says if a G is a finite cyclic group and Z is a group, okay, of an integer with binary operations addition, then G is isomorphic to Z. So what does the statement says here? So if G is a finite group, G another one finite group a finite group G another finite group group understand means finite. Sorry, there is infinite. We don't know any values. Infinite group and Z is an integer. Z is one integer with binary operation. When the other one value integer one binary operation addition okay, binary operation addition. Then G is a isomorphic to Z. G is isomorphic to Z. G is an isomorphic to Z. Okay, isomorphic to Z. So now let us see the proof of this. Okay, let proof. Okay, let G is equal to G is equal to A. G is equal to A and is equal to A raised to N by N belongs to capital Z be a finite cyclic group. Be a infinite cyclic group. Infinite cyclic group where A is the generators. Already know the value. What does generator stands for? Okay, so defining a mapping that is F colon G tends to Z by F of A raised to N is equal to N for all A belongs to Z. This is equation number 1. Okay. Here it will be 3 terms. Isomorphism first not a question noted, then G is an isomorphism. So isomorphism 3 steps isomorphism prove first step adu homomorphism first step homomorphism and second step 1-to-1 1-to-1 mapping 1-to-1. So third step is onto function So isomorphism prove Z is an isomorphism prove So first step homomorphism second step 1-to-1 mapping onto-1 equation third one onto system So before that what we should take? Let me consider G is equal to A and G is equal to A raised to N, then N belongs to Z. So because A raised to N we know the value of nth finite times. Therefore we took that A raised to N is equal to N belongs to Z. Be a infinite cyclic group. Where A is a generator. So it is the generator. Okay. Then define the mapping. So mapping and define already got G is an infinite cyclic group and Z is a group integer. Okay, with a binary operation. F colon G tends to Z prove G nenta Z mapping So therefore we write F of A raised to N is equal to N for all A belongs to Z. So A na Z belongs to consider okay. This is equation number 1. Okay. So next, first ಏನು prove ಮಾಡ್ತೀವಿ ನಾವು? First ಏನು ನಾವು to prove that F is homomorphism. To prove F is homomorphism. Okay. Homomorphism. So homomorphism is so for all we consider a raised to m. Sorry. For all a raised to m, comma a raised to n belongs to G, capital G. Considering this, f of a raised to m into f of a raised to n, that is equal to f of a raised to m plus n. Okay, so f of a raised to m plus n by the law of indices. So law of indices nagari ಏನಂತದ f of a raised to m into f of a raised to m into a raised to n ಅಂತದ ಈ ತರ ನೋಡ್ರಿ. law of indices ಇಲ್ಲಿ ಬರ್ತದ a raised to m into a raised to n is equal to a raised to m plus n. Okay, these are the basics of mathematics. So a raised to m is a raised to m plus n आता. So this a raised to m plus n can be written as f of a raised to m into f of a raised to n. Therefore we can written this as m plus n. Okay, or we can this can be written as f of a raised to m into a raised to n is equal to f of a raised to m plus f of a raised to n. Okay, this is by how the definition of 1 by 1. So idanna law of indices annu ನೋಡಿ scripts ಮಾಡ್ಕೊಂಡ್ರೆ by m plus n or you can skip this. You can skip this and directly write this a raised to n, f of a raised to m plus f of a raised to n. Okay, this is since the ಯಾವ ಫಾರ್ಮ್ ಹೇಳಿದಾರೆ f of a raised f of a into f of b. this form ಗೆ ಏನಂತೀವಿ ನಾವು ಈ ಫಾರ್ಮ್ ಗೆ homomorphism ಅಂತ ಹೇಳ್ತೀವಿ. So this is in the form of this, since f is homomorphism. Okay, hence we can say that f is an homomorphism. Okay, ready to understand it? We considering a raised to m into a raised to m comma a raised to n belongs to G. Considering this f of a raised to m into a raised to n ಈಗ homomorphism prove ಮಾಡದ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಎರಡನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ಇದು ಯಾಕೆ ನೀವು ಎರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ ನಮಗೆ homomorphism prove ಮಾಡುತ್ತೆ f is homomorphism ಅಂತ. So that f of a raised to m into f of a raised to n today by the law of indices we can write that a raised to m into a raised to n is equal to a raised to m plus n. Therefore we can keep written in the form of homomorphism definition or homomorphism expression, or we can say that homomorphism expression, that is f of a raised to m into f of a raised to m into a raised to n is equal to f of a raised to m plus f of a raised to n, since f is a homomorphism. Okay, so next in second proof it is first proof is homomorphism. To prove homomorphism, so second step ಏನಂದ್ರೆ to prove that 1 to 1. Okay, to 1 to 1 consider f of a raised to n is equal to f of a raised to m. That is that we can write this as n is equal to m. Okay, or a raised to n is equal to a raised to m by properties of indices, law of indices, by property of law of indices ನೋಡ್ರಿ. law of indices by text book indices ಅಂತ ಹೇಳ್ಬಿಟ್ರೆ law of indices ಅಂದ್ರೆ ಹೇಗಿರ್ತದೆ a raised to n into a raised to m or a raised to m divided by a raised to n ಇದು ಅದು law of indices. Therefore we can write that a raised to n is equal to f of a raised to n is equal to f of a raised to m. That implies a raised to n is equal to a raised to m. Hence this is an f is 1 to 1. Okay, 1 to 1. This is 1 to 1. Okay, so ಹೆಂಗ್ ಪ್ರೂವ್ ಮಾಡಿದ್ರು ಏನು ಪ್ರೂವ್ ಮಾಡಿದ್ರಿ 1 to 1 ಅಂತ ಪ್ರೂವ್ ಮಾಡಿದ್ರು. ನಾವು ಏನು ಹೇಳ್ತೀವಿ f of a raised to n is equal to f of a raised to m ಅಂತ ತಗೋತೀವಿ. ಎದುರು ಜೊತೆ ಅಂದ್ರೆ ನಮಗೆ ಏನು ಮಾಡೋದು 1 to 1 ಪ್ರೂವ್ ಮಾಡೋದು equal to 1 into 1 ಅಂತ. Therefore f of a raised to n is equal to f of a raised to m ಇತ್ತಂದ್ರೆ we can write n is equal to m or a raised to n is equal to a raised to m. Here also we write this f of a raised to n is equal to a raised to m. Therefore we have written a raised to n is equal to a raised to m. Hence it is an 1 to 1 mapping. So next is to prove that third main to prove that f is onto. F is onto. So we are having that for all n belongs to z. In statement only I said that it is n belongs to z, or that is a raised to n belongs to g. A raised to n belongs to g because there is g is an infinite cyclic group. ಯಾಕಂದ್ರೆ g ಅನ್ನೋದಂದ್ರೆ infinite cyclic group ಅದು finite value ಇತ್ತಂದ್ರೆ g a raised to n belongs to g ಆಗಲ್ಲ. It is infinite cyclic group ನಲ್ಲಿ ಅದ. So therefore a raised to n belongs to g. We have that f of a raised to n is equal to n that belongs to z. So f of a raised to n, the value of a raised to n is equal to n ada. So ಈ ಎರಡು belongs to answer ಇದು as well as it belongs to z. Therefore every element n belongs to z appears as an image of some elements a raised to n belongs to g. Therefore thus f is onto. That is f is isomorphism from g onto z. Okay, so idunu prove aitu. Since prove that f is an onto function, so we already know that n belongs to z or a raised to n belongs to g. Yakandre illi f is an infinite group ada adake. So we have write f of a raised to n is equal to n that belongs to z. For every element n belongs to z appears as an image sum of elements a raised to n belongs to g. Therefore thus f is an onto mapping. So ಏನilla f of a raised to n belongs to z ada, as usual n belongs to z ada. Therefore every element of n belongs to z that appears as an image. We already said image and pre-image. So into x square is 2x ಅಂತದ. Okay, the image the pre-image ಇದೆ ಇಲ್ಲ ಅವರಾಗ. So therefore f is an onto function. Okay, so last of this chapter, so ಈ chapter ನ last exercise ಒಂದು problem ನೋಡೋಣ. problem ನೋಡಿ ಈ chapter wind up ಮಾಡ್ತೇನೆ ನೋಡಿ ಇಲ್ಲಿ. So example show that the mapping f colon r plus tends to r raised to plus into a binary operation. So dot is multiplication. So defined by f of x is equal to e raised to x for all x belongs to r is a homomorphism and in spine its kernel. Okay, so question is show that a mapping. So mapping prove ಮಾಡೋದು ಹೆಂಗಂದ್ರೆ f colon r plus tends to r raised to plus into a binary operation. So into multiplication ಅಲ್ಲಿ it is a multiplication ಅಲ್ಲಿ addition ಕೊಟ್ಟರೆ multiplication defined by f of x is equal to e raised to x. Therefore x belongs to R is a homomorphism. Hence find the kernel. So x belongs to R is a homomorphism. F of x is equal to e raised to x is a homomorphism. Already ಹೇಳಿದ್ದಾರೆ ನಮಗವರು. So there is nothing much in this solution. So you know to fill a solution. So already we know that x comma y belongs to R. For all x comma y belongs to R, considering. So already namaga x belongs to R and we are considering two terms here. X comma y that belongs to R. Therefore, f of x plus y. Therefore, f of x plus y is equal to e raised to x plus y. Therefore, we can write e raised to x into e raised to y, or we can write f of x into f of y. Okay. This f is an homomorphism. This f is an homomorphism. So here consider f x comma y belongs to R. So considering the homomorphism definition, f of x plus y is equal to e raised to x plus y. Already we know f of x ಏನು value e there to value. So f of x plus y is equal to e raised to x plus y, or we can write these steps as the different by differentiating by the law of indices. The law of indices x raised e raised to x into e raised to y. Therefore, after that we can write f of x into f of y. So after that here f of x plus y is equal to f of x into f of y. So ಯಾವ form ನ ಇದೆ ರೀ homomorphism form ನ ಇದೆ ಹೌದಾ. Therefore f is an homomorphism ಅಂತ ಕರಿಬಹುದು ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ. Okay, f is an homomorphism ಅಂತ ಕರಿಬಹುದು. Okay, so next, to find kernel. Afterwards, to find the kernel. To find the kernel. So kernel ಅಂದ್ರೆ ಏನು? We know the identity. We know that the identity of R raised to plus into a binary operation means multiplication is 1 is equal to e raised to n, that's e raised to 0 or e raised to 1. So nothing value is e raised to 0 ಆಗಿರ್ತದೆ. Therefore f of 0 value ಏನಂದ್ರೆ nothing ಬರ್ತದೆ. The kernel of f of 0 is equal to the kernel of f of 0 of f is equal to 0. So ಏನು ವ್ಯಾಲ್ಯೂ ಇಲ್ಲ, e raised to 1 ಇರ್ತದೆ. e raised to 1 ಇತ್ತಂದ್ರೆ e raised to 0 ಆಗುತ್ತೆ. e raised to 0 value ಅಂದ್ರೆ f of 0 value. So f of 0's value is anything to multiply with 0 is so 0 ನೇ ಬಂದಿರ್ತದೆ. Therefore kernel of f is equal to 0. So after that, next you try about these other examples. If you have any doubt, you can contact. So thank you. We'll stop this class here. We have finished the topic groups, and in tomorrow class I will be explaining about the time and application.